Hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date time is 2025 October 28th. It is 2020-50, as in, well, now it's 51 past 10 p.m. And well, the last time I recorded was I think 12 days ago, was it? Yeah, 12 days ago. And well, it took me some time to actually get my head around everything and try to organize everything in a more coherent manner. Although that does not mean that what I'll be covering and therefore dumping in this video will be absolutely coherent and well organized. In fact, it could sound the opposite. But, I'm doing this for the purpose of leaving records, like, so that I can refer to this in the future. Sort of like an archive, because I always forget what I did or what I had done. That happens. So, in my last video, I remember saying that that I wanted to go back a bit and rerun some tests, rerun some iterations with some new hyperparameters, namely the maximum population size, now set to 100 from 400, when doing pseudo-chaos and pseudo-chaotic dynamic, and compare in terms of well, mainly whether I get true ceilings or not. So let me write that. Or no, let's, because the last time, the last video covered true. That looks like a duck. Okay, I'll just use this. That is too small. Maybe maybe I should zoom in more. Ooh, that's way too big now. There. True chaos. True. I don't know how to spell. True chaotic. Yeah, this was the last video, and then the way it worked is that, let's put this somewhere here or here. Good. And the reason I moved this about is that I would like to do I'd like to have some kind of a flowchart. There. Next step, as I remember having said in the very last video, was the next thing would be the true chaotic dynamic. Yep. Or true chaos dynamic, or true chaotic dynamic. I don't know. But I also said before I do that, I wanted to compare. I wanted to compare pseudo Is that how you spell sudo? Yeah, it is. No, I mean EU. Sudo chaotic, and also sudo chaotic dynamic. So this and this I need to compare. I mean, these two, I've done that in one or two of my previous videos, but these two, this relationship and this relationship or comparison, I haven't done it yet. But in order to do that, I had to, like I said, I had to reduce the population size, the maximum population size, from 400 to 100. That's for pseudo-chaotic. For pseudo-chaotic dynamic, it would be 40 to 400 to 10 to 100. Okay. And well, see if I get, yeah, why, to see if I get true ceilings, any true ceilings, because at this point 1 or 2 true ceilings is all I want, because they're so rare to well, because they're just so rare ever since I moved from here to true chaotic, from pseudo chaotic to true chaotic. So that's the purpose. That was the purpose for the last 12 days. And yeah, let's have a look. Nope, hide that. So first off, it will be this one, pseudo chaotic. Let me just move a bit. So the first one would be pseudo chaotic, with the maximum population being set to 100, and previously, when doing the grid search or grid searches for true chaotic, and when I used the relu-like function for the learn from others, for the entities, well, what did I get? What I got was, I had 3 out of 240 in one grid search, 240 being the number of entity event ratio combinations. And in another grid search, I had 1 out of 240. So to make this simple, I'll just put this at 4 out of 480, which is what? 1 over 120. 1 over 120 is what? I know it's less than 1%, but it's like 0.0, no. What is it? Oh god. What did you press? 0.83% it says. So when I did pseudo chaotic and then I decreased the maximum population from 400, I know I'm repeating myself, 400 to 100. Well, at first I just ran the simulations. I just had them run without actually designing a framework for grid search. I just wanted to see how I should design it or repurpose the code. The entity event ratios for MLP see the chilling exists is implied in this case. This was 40%, this was 40%, and this was 40%. So when I do that, I ran it for give me this one. Nope. This was the first attempt. Chaos 2025 1016, and the maximum ever in this case was 2855. So close, but sadly not exactly the true ceiling. Okay, so next run. What happened? In the very next run, I got 2860. So still 5 short. So well, better luck next time. And then the third run, I got 2865, the actual true ceiling. The entities have converged. So I also had a look, that's not it, I also had a look at the entity distributions. This is at the end of the first era, second era, third, fourth, and on and on and on and on. This is the last era, same as this one, and we can see that at the end of the last era we just lost the true ceiling, but at the end of the second last era the true ceiling was still there. As you can see, there were 13 of them, 13 entities that were at the true ceiling. That is this bar right here. But sadly in this case we lost them, but the point still stands. It's easier to lose a whole variation of entities in this case. In this case being the entities that were at the true ceiling. It's easier for them to just vanish because there are only 13 of them, and the maximum population is set to 100. This the only way to mitigate this, or well, an easy way to mitigate this, is to increase the population size. But since that's not what we're doing right now, it's pointless to argue. So that was the third run, and the fourth run, the maximum ever in this case was 2855. Let's have a look at the entity distributions. Still very similar. Okay. Yeah. Well, in this case, you see that the third, at the end of the 8th era, since this is 7 and it's a 0 based index, so 8th era, the distribution looked quite nice actually. But anyway, we still the entities still did not manage to get to the true ceiling, but already I only did 4 because I felt that it was now unnecessary, because I only did 4. Give me purple, purple please. I only did 4, and out of the 4 times there was once an instance, or as an iteration of evolution where I got true ceilings. So already here it's I know I'm assuming a lot, but I think it's quite safe to say that 1 over 4 is a lot bigger than 1 over 120. I mean, if I repeatedly just run this, since this is like the benchmark, this setting is like the benchmark 40-40-40, and yeah, this benchmark when doing pseudo-chaotic and pseudo-chaotic dynamic. If I repeat this, I know this will change. This is likely to change. It could be 1 over 3, or it could be 1 over 7, it could be 1 over 12, etc. But it is very unlikely, it would be very unlikely, for this to be any smaller than 1 over 120. So I just stop there. With this score, I already have a point. I didn't prove a point, but I already have a point. So the next thing I did was, well, obviously, was to go do pseudo chaotic dynamic. That is so not pretty. I think I'll just stick to just writing it in a sloppy manner. The next thing I did was do pseudo chaotic dynamic, where the population size would, well, before it would have started from, for example, 100, increase by 100, all the way to 1000, or start from 40, increase by 40, all the way to 400. But in this case, since I'm trying to compare with true chaotic, again, I know I'm repeating myself, but I think this is very important. And that's not such a good color. The population size, the population of entities would start from 10, increase by 10, all the way to 100. So the world sum utility plot would look something like this, and the this would be blips, this would be summed util. Anyway, oops, yeah, but the other stuff would be the same, meaning this stuff will be the same. Oh, that's quite amazing. Yeah. So I did that. How many times? I did that 7 times. And those are these ones. Okay. There. Well, actually. Okay, what to do, I'm so bad at this. I am just going to reorganize the stuff. I know I should have done this off camera. But doing it now. Oops. Okay. So I shouldn't do this. No, I shouldn't. They all have the same names. I'm so bad. Anyway, I'll just have to do this manually. So this is the first run, and the maximum ever was 2814. Okay. Actually, let's not do it like this. Oops. Here's the second one. Second run, the maximum ever. The second run, the maximum ever was 2825. Yeah. Third run, 2850. Fourth run, 2860. Oh, that's good. And 2850 again. This is the fifth run. Here we have the sixth one, 2855, so quite close. And the last run at 2850. So, out of the 7 times, I had, when doing it like this, out of the 7 times, I had 0 occurrences of true ceilings. But yeah, but I still believe that 0 out of 7, when done enough, multiple times, more and more and more and more, is going to be bigger than 1 over 120. It's a hunch, but yeah. Hold on. Okay. Yeah. So you just close all this. Also, let me get some water. So what's next? Well, next, I just compared pseudo-chaotic to true chaotic, or rather, I ran pseudo-chaotic given the same hyperparameters that I used for the true chaotic, and did the same for pseudo-chaotic dynamic, and I was given or provided some proof to some degree that that true chaotic sucks. It's really hard to say. I mean, it hurts to say true chaotic sucks. And spoiler alert, true chaotic dynamic sucks even more. To be even more honest, if I were to optimize in order to get a solution or a set of solutions, solutions that were limited in number, I mean, I would resort to using pseudo-chaotic or pseudo-chaotic dynamic. But since I said that I wanted to know more about true chaotic and true chaotic dynamic, I had to go on. So give me a second. Alright, I'm back. So, and I got the results ready. So the first run of grid search involving 240 entity event ratios combinations. Here's what it looked like. I even wrote down the numbers for the maximum errors for the world summed utility score. And here we see that the scores and for these I ran the 240 entity event ratio combinations 4 times, so that's 960 iterations with these. Actually, let me just copy this. Oops. There we go. Nice. Now zoom back in. So here we go. Now, here I have the world sum utility values per entity maximum ever of world summed utility values, or one value actually, per entity event ratio combination, and overall the shapes of these curves or plots are the same. This is something that we've seen in the last video, but the only difference is that in general these maximum evers are lower, because if I were to bring up that one, this is from the this is when I had 3 occurrences of true ceilings, and although I don't have the numbers at each data points, if I were come on there, if I were to put these two side by side and just compare them, well, if you look closely, so one thing to note is that the scores are lower, although the plots don't look like it, and that is because the y-axis are different. I'll go for blue. This one starts from 2000 and ends at 3200, whereas on the left, for the chaotic dynamic, it starts, I think this was 1500 maybe. So for example, if I were to actually make this look better, yeah, looks about it. And then I should put this right here. This is what it would look like, or something like that. So when the scores are lower while doing true chaotic dynamic, they are considerably lower. Which is why I had to lengthen the y-axis for every plot. And it's not just about the scale either. If we have a look at the scores, the absolute scores, quite often they are very close or below, very close to or below 2800, which should actually be easy for the entities to reach and go above. But in this case, when doing chaotic dynamic or true chaotic dynamic, that's not the case. That's not so easy. zoom back in more. Nope, there we go. So not many of them are above are equal to or above 2800, which is frustrating because it means that the entities are not being given enough time or resources or examples for them to learn from, or for them time for them to evolve and change, and examples for them to learn from. Since I said that in my last video that when the entities are actually given some good examples within a span of 2 to 3 blips, they will, a lot of the entities will learn from those few examples, and they'll start converging very, very fast. But in this case, that doesn't happen. Maybe here, 28, 25, and that was MLPC. 25% for mutation, 30% for learning, 5% for procreation, and 40% for chilling. So that one was we got lucky there. But usually, no. Very underwhelming. In this, at least in this grid search run, it's very underwhelming. So let's go over to the next one and see if this trend continues. Here we go. This is the next one. Second run of the grid search. We have one occurrence where it's 2815. No. 2810 we have, which is 1758 520. Another 2810, that is 25 49 6 and 20. Okay. No. Yeah, that's about it. Okay, next run. No, we got really lucky here. We have 2840 right here, when the entity event ratio was 43, 53, 4 and 0 for chill. Then we have 2810, 2800, 2805, no, 2830 there, which was at 2654 and 20, 2820 there at 1550, 530, 2825 there, with the entity event ratio being 23, 44, 3 and 30. 2830 there at 16, 30, 4, 50. Yeah. I mean, here, what we can notice is that when doing chaotic, true chaotic, in brackets, chaotic dynamic, because the entities are not actually being given the right amount of time or blips per era, within an era, because an era well, every era, the number of items, the number of genes will increase with every era. So the era needs to continue on long enough for the entities to kind of converge. And since well, since the eras will just continue as the blips would also continue, probably like 10 blips per era. So there are 10 eras, so that's 100 blips, and then 10 blips per era. So when doing chaotic dynamic, the the maximum errors for the sum utility value is likely to be higher when the event ratio for learn is higher than the event ratio for mutate, which is obvious, because by doing this, or well, actually by doing this, the entities are more likely to learn rather than just randomly mutate, given their own individual mutation rates. But anyway, and by doing this, the entities are more likely to converge. Yeah. But this is all. Well, actually, I should get. I don't know. I should get to that later. The last one. No. Is it the last one? Yeah, it is the last one. The last grid search. Here we have 2830 here again, the learn being twice as high. And again, the learn is almost twice as high. 2810. This, I think this is an anomaly. Anomaly here. 36, 28, 6, 30. 2810. 2815, 2815. Yep. Still the learn event ratio is higher. 2810 there. Learn ratio is slightly higher. Yeah, so if you want the entities to converge, whether they're actually the true ceiling or not, the learn event ratio should be set higher than the mutate event ratio. Okay. Let's then have a look at, not that. Oh, well, should I? Yeah. I should then have a look at the, well, let's have a look at the time it takes. All right, fine. I think that's it. No, actually, let's have a look at the entire gallery of summed utility plots. There we go. Hmm. It's not so pretty, is it? Now they're all mixed up. Now here we see that, or we should be seeing, the staircase. And when we don't see the staircases, it means something is wrong or something's not optimal. See, for instance, this one where mutate event ratio was 46, and for learn event ratio it was 0. So this is probably this could probably serve as the vanilla, or just like a control group, or it could be worse than the control group. See, the steps aren't forming, not as much as I would like. What is this? This is 1% mutation and learning. Oh, but this is very interesting though. It's 1% for mutation, 55% for learning, and 4% for procreating, and 40% for chilling and existing. But here it looks really abysmal during the first 130 data points, and all this is 100 lives, but during the first 130 data points it looks very, almost nothing. It looks like almost nothing, and that would be due to the very low mutate event ratio. And like I said, from the very beginning, mutation is the only source of any form of progress. Like I said, 0% for mutation means nothing is actually going to happen. So even when the learn event ratio is 63 times higher, you'll still get this. And the maximum ever is what, a measly 28, 21, 25. So it's not ideal. See, this is better, but we're still at 2810. So this is see, you almost had me here. It's 2685. And it's supposed to be 2865. So it almost fooled me. So that's what it looks like. Let's have a look at the number of data points. And that's not such a. There we go. So this is. Copy this and hello. Seriously? Am I copying or am I copying? I have no idea why it just froze on me. Please don't freeze on me. It is freezing on me, or not. Oh no. I actually had it here. There. It didn't freeze on me. I just didn't find it. How silly. So, here we go. This part, red is a bit, I'll take it orange, and here we go. This part is a bit thicker, thank you. This part is when the chill ratio is 0%. This part is 10. This part 20, 30, 40, and 50. Now, the number of data points increases as the chill ratio increases quite a lot when compared to this. Hello? Yeah. See, it increases quite a lot. Is this like the end? No. Well, it is actually almost on the edge. So it increases. Well, quite a lot, because the highest for true chaotic dynamic is somewhere close to 480 right here. However, the highest here is below 400, and there is almost no correlation between chill ratio, chill event ratio, and data points, data point counts, data point count. However, on the left there is a correlation. As the chill ratio goes up, the data point count goes up. And that is actually the same for the other grid search results. And of course, the time taken also increases, but not as dramatically. Well, the slope isn't just that big. Come on. If you compare these slopes, it's really like not that big. Still, there is a bit of a correlation there. Like, do I need a brush? Yeah, there is a bit of a correlation there. Give me this. But not as, not that steep. And this is what the maximum ever average per group looks like. So, there. This is what the maximum average per group looks like, and this also may seem like there's a bit of a correlation between the chill ratio and the maximum ever average per group, grouped by chill ratio. But let me just check the other ones. 2. Yep. Yeah, we do. So it's probably a good idea to set the chill ratio at least 30, somewhere here. From chill event ratio should be 30 to 50, something like that. So maybe like set it to 40 or maybe 35, you know what I mean. So it should be a good idea to just test in these areas. And I think testing in these areas is a good bang for buck. I think that's how you should say it in this case, because the data point counts increase quite drastically. However, when compared to the time taken here, they don't increase that drastically. But these two are costs. Well, the time is a cost. The time taken is a cost. But compared to the increase in this cost, the increase in the maximum ever average per group is bigger. So I think it's a good practice to set the chill event ratio somewhere between 30 and 50, or maybe something like 25 to 50. And this could change, this could fluctuate, It could sometimes be 27, it could sometimes be 43, things like that. So, the conclusion is that I have to say, where's my mouse? Can I forgot how I do this. Oh no. Oh, there. Nice. Give me 30,000. Yeah, I should do it. I just hope I don't blow up my computer. Did I do it? What did I do? I don't know. Maybe I should have done that. Okay, I'll just stick to this. So, coming back here. Zoom in a bit more. Failed to produce true ceilings. With true chaotic dynamic genetic algorithm. And I think then Why, I should ask? I think the biggest reason, obviously, is that the population size needs to be bigger, as in not 100, but 400 at least, 400 plus. So not 100, but 400 plus. And the second reason could be that I need to give the entities more time for entities to converge. Caveat there. In each era. Or in a series of eras that kind of relate to one another, that are quite similar. But the thing is, I still think that this is way more important than this. This is way more important. And whenever things go from, well, for example, when doing true chaotic, and then from true chaotic doing true chaotic dynamic, the maximum ever for the world sum utility value tends to drop somewhere around 2 to 3%. So true ceiling, for example, being 2865, and then when doing dynamic, for example, it would be 2810, sometimes 2030, and on and on. Yeah. And I think because the population size, the max population size is set to 100, the moment entities converge, when they converge, they don't change. Duh. And this is due to the fact that I've implemented a lot of measures to lessen the effect or make it less likely for the entities to mutate once they reach some point. Every entity would have a different mutation rate, individual mutation rate, and on and on and on. And sometimes the entities just chill, right? And they, when they don't MLP, mutate, learn, or procreate, they chill. I think and I think it's a guess, it's a hunch, it's a guess, I'm only speculating those are all same words. In order to mitigate the effect of this convergence at a unsatisfactory point, I need to shake things up. Shake things up a bit. And since I'm already doing the dynamic version of true chaos, I think I can try the same with varying the values, as in varying utility values and varying the constraint values. Yeah, for the individual entities. But since the world part of the evolution judges the sum utility values of individual entities, maybe I can just actually, yeah, I can do that. Sorry. I can have the world.bin apply random or somewhat random, but still following random utility values that follow the distribution, like I did for when I was doing the dynamic genetic algorithm. And I could have the entities when they evaluate themselves use a set of constraint values that follow a distribution, but that are somewhat random within that distribution. Again, from the dynamic GA, not true chaos dynamic, not true chaotic dynamic, but just dynamic. What I did in, I think that was May, June. So yeah, and the expected effect, the anticipated effect that I think this would have is that it will shake things up. It will really shake it up, meaning when the entities converge, some are likely to disappear, some others that were somewhat underappreciated could be appreciated just right enough for them to earn their places, and so on. So yeah. And since this ties nicely into the other future plans, I think I should do that next. Also, find a way to run more than 300 or 400 processes on my laptop. I think that would be a huge achievement. It wouldn't be a theoretical achievement, but it would be a skill achievement. It's a skill issue for me right now. So yeah, skill-wise, it's a huge achievement for me. Theory-wise, not so much, but skill-wise, oh yeah. So that's about it for today. Thanks for watching. Yeah, that's when it comes to all the interesting stuff. That is about it. Others, I don't know, but I still have all the data, so and all the nice pictures. Okay, thanks for watching. Bye.